I am Arvind from Rajalakshmi Institute of Technology Mechanical Department. Today we will deal something about power steering system, suspension and braking system. Before going for the lecture here, I will like to convey a thing about this. I have referred some YouTube videos and materials for the presentation. Just go through the videos for the further improvement. So initially the power steering system, suspension and braking systems are taken into consideration. Initially we will deal about the power steering. In power steering system there are hydraulics, pneumatics as well as an power circuit. So first one, power steering hydraulic. Power steering hydraulic is nothing but we are using one external fluid for creating the steering system in a smooth and flexible way. So here in power steering system, this is the unit, this is the power pump unit. From pump the fluids are taken here. From here the fluid is taken to the cylinder assembly. Here the hydraulic piston is actuated using the fluids in and out circuit. Initially this is the rack and pinion arrangement. When the driver is turning the wheel to the left or right, based on the connectivity, rack and pinion gear will work. Based on that, the wheel alignment will change to left and right. But using the power system, when the fluid pressure is taken here, when I am turning the steering wheel to the left hand side, the wheel will be turning to the left. So the piston here, this system, the fluid will be flowing here. This hydraulic piston will move to the right hand side. It will help the system to turn in a proper way. So using this pump and power circuit, we can turn the system in easier way. This is the extended version of the diagram. Here the fluid pressure comes in, the piston can move to the left or to the right. Based on that the wheel alignment will change. This is nothing but the power steering in hydraulic. The next one, the power steering in electric. The electric power steering is nothing but these are the common things which we must involve in the electrical system. First one is steering angle sensor. How much degree the rotation is turned. Next, torque sensor. What is the torque input we need for the rotation, and the vehicle speed sensor. All the wheels are how much speed it is rotating. All the three inputs are given to the electronic control unit. For electronic control unit to operate, battery system we need. So from the power, battery is energized. From ECU, using the battery, the ECU is energized. Using that steering angle sensor and vehicle speed sensor into consideration, it will give the input to the motor. In motor, how much rotation it has to be turned. So here is the system. Here the rack and pinion arrangement is there. When I am giving the rotation, how much degree, from 0th degree to how much degree of rotation I am gaining. Based on the input to the ECU will send the power to the motor. It will send the input to the motor. The motor will function based on this circuit. Using that motor rotation, the reduction gear will act. So this is the extended diagram. When I am giving input to the system, here is the gear rotation. This gear rotation will give the input to from here is that power motor. The motor is rotating here. Usually the motor rotation, this gear wheel is rotating. But in this kind of system, to have the efficient work output, we are replacing this system with the epicyclic gear train. Why? Because if this system motor is not functioning properly, it will stop abruptly. There will not be any rotation there. So to stop the rotation in a flexible way, I am giving the epicyclic gear assembly. This is the sun gear and these are the planet gears. And this is the ring gear assembly. When the motor rotation stop, using this sun gear, the rotation will transfer to here using the planeting gear setup. So there won't be any stoppage in this here in the circuit. So this is the power steering in electrical mode. The next one, we will deal about the type of suspension system. Broadly it is classified as independent suspension system, non-independent, and air and hydraulic electric suspension. These are the four major systems. We will deal about each and every system here. So first one, independent system, MacPherson strut. This is the independent system. Independent system is nothing but for each and every wheel, this type of arrangements will be there. What are the arrangements? The brake house will be there, the spring house will be there, strut turret mounting will be there, and strut mounting nuts which were holding the strut, and the steering arm. This is the working animation diagram. Nothing but this is the strut assembly. When this wheel is going along and bumps, using the spring, initially the spring will compress, and based on that here the piston assembly will be compressing. So for each and every wheel this type of arrangement will be there. So we can transfer some pressure or some bumps to the wheel itself. So it will not be viewed in the cabin. So this is the independent suspension. Independent suspension is nothing but individual suspension will be there. So this is the wishbone circuit. This is the type of wishbone design. this is double wishbone design, this is a single wishbone design. So this is the animated view. These wishbones are connected to the frames. So here is the spring. When the tire is moving along bumps, using this spring circuit, this wishbone will act compressive state either to the up or down. So using the system. So this is the wishbone circuit. The next one is vertical guide. Vertical guide is nothing but in the frame, vertical movement will be there. This vertical movement will be consolidated by the rod here. The rod will move up and down based on the compressive state. So this is the vertical guide. The next one is trailing link. Trailing link is nothing but after the wheel alignment, the link will be there. This link will be mounted with spring to the frame. When tire move along the bumps, here using this trailing link, the spring compressive state will attain, so tire can move up and down freely. It will create a suspension. This is trailing link. The next one, swing off axle. The name indicate off axle. Off axle is nothing but this is semi and this is semi. It will act individually. There is no connection between the overall axle. When this go along the bumps, this part alone move up and down. Similarly, when this tire move along the bumps, it will move up and down. There is no connection between this. They are interconnected by an hub. So swing off axle is nothing but this will be acting as a separate axle and this will be acting as a separate axle in a single axle circuit itself. The next one, the air suspension system. So initially we have dealing about the independent suspension. The air suspension is separate, it will not come under that. So air suspension system, what are the basic components? So basic components is engine, a compressor unit and a control valve. See here, from the control valve, there are totally 3 alignments to that valve. What are the 3 alignments? First one is control valve, second one is return line and third one is level valve. Purpose of level valve is to maintain the pressure, air pressure inside the valve, and the control valve is nothing but it will decide how much air should be given to the bellows. This is nothing but the bellows circuit. So this part is nothing but the bellows, and for bellows, using this control line, it will send the pressure level to the bellows. The pressure level can activate the bellows up and down. If the pressure level is high, the return valve will return to the control valve. This pressure line is used to check the pressure level. It should maintain the pressure level for the braking circuit. If I want to brake, a sudden brake is applied, the suspension system will act accordingly. It will send the pressure level. It will maintain the pressure level. The next one is hydroelastic suspension. Hydroelastic suspension is nothing but there are interconnected lines between the either side of the wheel. Which means if the car is viewed from here, these 2 wheels are connected by connected lines. In other way, that side the 2 wheels will be connected with an interconnected line. When it experiences the bumps, the fluid pressure will be energized. This is the diagram. When here I am experiencing the bumps, it will press the diaphragm here. Diaphragm is a rubber type material. When the diaphragm is energized, here the fluid will be circulated using this tube. This tube is mentioned in this line. This fluid pressure will indicate the bumps to this wheel, so this wheel will act accordingly. So both the wheels will experience the bumps in a smoother way, so the suspension will be simpler. This is the hydroelastic suspension. Hydro is nothing but the fluid, you know. This elastic level is created using this fluid pressure. The next one, non-independent suspension system. Non-independent means both the axle will face an effect. Here the first one, solid axle leaf spring. Leaf spring, you know. So these are the several metal plates are arranged in a group. The leaf spring will open up or close based on the bumps I am attaining or based on the weight I am giving as an input. This is the solid axle leaf spring suspension. The next one is solid axle coil spring suspension. Coil spring is nothing but by replacing the leaf spring I can use the different coils for a single axle. Single axle will attain the 2 coils. Why 2 coils means it can withstand the axle for a longer period. The axle can maintain it for a longer period. So solid axle coil spring is replaced instead of solid axle leaf spring. So the next one, braking system. The braking system will have, the first one is pneumatic braking system. Pneumatic is nothing but an air input. I am going to give an air as an input for the braking unit. So here I need a compressor system. This is the control valve. This is the brake pedal. When the brake pedal is pressed, the green level is it will indicate the green level to the downward position, so that air can enter to this tube to the 4 level. Here the 4 level I need is, this is the 4 wheels. Here the spring unit is needed and center cam unit is there. So when the air is given as an input, brake pedal is pressed. This air will get entered to the diaphragm level. It will compress the spring. The spring compressive state will activate the cam, so that in vertical position of cam can move to the horizontal position. It will end the drum to the connected level, so it will apply the brake. So for 4 wheels, this brake assembly will act to the tube. This is the pneumatic braking system. The second one is hydraulic braking system. Hydraulics is nothing but I am using a oil here. Here the master cylinder is used for the oil storage. From the oil storage, this is the control unit. First, this is the drum brake. Sorry, this is the disc brake. This is the drum brake. For disc brake, this is the assembly. In this assembly, this is the disc plate. Here the oil will be coming to this direction. It will compress the level. The green is the rubber material. It will compress. So here for a disc brake, by replacing the cam, in a pneumatic we are using the cam here. Here the piston cylinder assembly used. The fluid will be coming. The violet color is the fluid line. The fluid level will move the piston green color to the right hand side position, so that this wheel can abruptly stop the drum system. So it is the hydraulic braking system for the drum brake, and this is the setup for the disc brake. So this is the hydraulic braking system. Here we have to look into the master cylinder assembly. When the brake pedal is pressed, the master cylinder will be activated. This master cylinder will send the control level to the control system. How much of brake, whether the little brake is necessary or abrupt brake is necessary. This control unit will decide how much fluid pressure or fluid level I should give as an input, either to the disc brake or drum brake. This is the hydraulic braking system. The next one is ABS. As you all know, this is the symbol for the ABS in your vehicle, the anti-lock braking system. Normal braking system is when the brake pedal is pressed, the brake is applied to the wheel abruptly. This ABS system will act such that there is a modular unit in the system. The modular unit will send the braking input in some separate gap. It will apply the brake. It will give some idle time. Again brake. Again idle time. Again brake. Again idle time. This level of system is used. It will helps to attain the steering wheel. It will not control the steering system. So you can easily rotate the steering system while applying the brake itself. This is the help of ABS. So this is the ABS module. First, initially, the ABS module will get an input from all the wheels. Why we need input from all the wheels is at what speed every wheel is rotating. That wheel speed sensor the input is given to the ABS module. When I am applying the brake system is applied. It will send the input to the ABS module initially. How much of brake I should get? It will from brake control unit, from all the input of the wheels, brake control unit will send a pulse, which will initiate the braking system. The braking system will act. First it will press, then release, then press, then release. Even if you are applying the brake continuously, if the pedal is pressed continuously also, the brake pressure will be relieved, pressed and relieved, pressed. This kind of notation will happening. So that the car will not skid at any point of time. The driver will get the steering system abruptly in any type of rotation or any type of braking distance. So this is the working of ABS. We need wheel speed sensor at every point. So wheel speed sensor is given to the ABS logic circuit. Here the modulation valve is used. This modulation valve is send the hydraulic pressure, the pulse, to the brake application. This brake application will decide whether to press or release the brake circuit based on the single pulses. So this is the block diagram. So next one, the advanced version of ABS is nothing but the electronic brake force distribution system. EBD system is nothing but if I am alone driving the vehicle, there is some stoppage is there, some disturbance is there. If I am operating the vehicle, if I am applying the brake there, the vehicle will stop at some point of time. If here instead of me, there are totally 4 to 5 members sitting out there, and I am keeping the luggage also. If I am applying the brake, if there is no EBD system in your vehicle, the vehicle will attack the disturbance. If the EBD system is involved here, it will stop not in this gap, some distance away from that gap. How it is happening? So it will consider the overall input from the wheel speed sensor. The wheel speed sensor will send the input to the control module. The control module will decide at how much speed each vehicle should be happening. So initially, if the force is distributed, because 4 to 5 members are sitting out in the vehicle, and here luggage also is given as an input, so overall forces are distributed throughout the vehicle. So this force distribution will send an input to the pulse. This modulator unit will decide how much force should be distributed to each and every wheel, so that the wheel can be stopped at any point of time based on the disturbance created in your road. So this force are measured then and there based on the weight carrying capacity of the vehicle. If overall weight carrying capacity is attained in your vehicle, it will send the brake pressure, brake fluid pressure based on that, so that vehicle can stop at any point of time. This is the electronic brake force distribution system. So this is nothing but the traction module. You know the traction, right? If traction module is off, this is the setup, and if it is on, this is the setup. What is traction? Traction control is nothing but if you are operating the vehicle in a dry surface, if I am meeting a 60 rpm, all the wheels will be attaining a 60 rpm level only. If one wheel is experiencing the wet surface there, this normal wheel will be functioning at 60 rpm, and the wetted surface wheel will be functioning at 80 rpm because the wheels will be wobbling. So wheels will be spinning, sorry. So to avoid this, the traction system is involved. What is a traction system? Traction system will maintain the equal speed to all the vehicle, even though if we are experiencing the wet surface here. What it is does, here the wheel speed sensor is, the yellow color line is your wheel speed sensor. From the wheel speed sensor, every input is given to the ECU module, electronic control unit module. Here from the electronic control unit module, at how much speed the vehicle is functioning will be sending to the control modulator. If one wheel is experiencing 80 and others 3 are experiencing 60, it will send, and control modulator will send the pulse to that wheel alone. That wheel will help in reducing the speed. This control modulator will help to maintain the speed level of each and every wheel at the same position. If this is 60, this is 60, this is 60, and this is 80, I have to reduce to from 80 to 60. So the control modulator helps it will connect it to the braking system. The braking system will apply brake to this wheel alone to make each and every wheel rotate in the normal way. So the traction control is achieved. This is a traction control unit. So hope so you have some clarity around this subject. If you need more reference, kindly refer to the internet for the more advanced. Thank you.